y'all. So you should have just watched the slides for our vocabulary for this week. So if you remember, our vocabulary words that we're going to be using this week are factor, common factor, greatest common factor, prime number, and prime factorization. So all of those 5 terms are very important for what we're doing this week to help us find the greatest common factor. So what we're going to do today is I'm going to practice teaching y'all how to find the greatest common factor using what is called the ladder method. So I'm just going to do some examples on the board over here, and then I'm going to pull up your guided practice. So right now, if you want to work along with me, you can. I would suggest getting out a clean sheet of paper and a pencil and possibly pausing this video just so I'm not continually talking while you're trying to get that stuff. And then when it comes to the guided practice, I will explain to y'all how you can complete that while working it with me. So again, what we're trying to find is the GCF, which is the greatest common factor between 2 or more numbers. So right now, let's say the 2 numbers I want to look at are 12 and 18. So like I said, we're going to be using the ladder method. So I'm going to draw a line, kind of like an L, surrounding the 12 and the 18. So now on this side, I want to list a factor that they have in common. Now what I've told my kids in the past is like an easy way to think about this is if the 2 numbers we have in the ladder rung are even numbers, they are automatically divided by 2. So 12 and 18 are even numbers. So I'm going to put a 2 on the outside because 2 can go into 12 and 2 can go into 18. 2 is a factor of 12 and 18. So now I'm going to draw another line. You see we're creating a ladder. And now I'm going to divide 12 by 2 and 18 by 2. So 12 divided by 2 is 6. So I'm going to put 6 down here. And then now I'm going to divide 18 by 2. 18 divided by 2 is 9. So now we're going to do what we just did at the top for 6 and 9. Now, unfortunately, 6 and 9 is not so easy. They are not both even numbers. So I can't just divide them by 2. So I would suggest going to the side and kind of creating a table for 6 and 9 and just list all of the factors that 6 and 9 have in common. So I know I can automatically multiply 1 and 6 to get 6. I want y'all to think right now while I'm trying to think, what else can I multiply together to get 6? If you thought 2 and 3, you are correct. Now there's no other numbers that can multiply together to get 6, so I'm going to move down to 9. Just like how I did in the beginning, I know that I can multiply 1 and 9 to get 9. Now is there anything else I can multiply together to get 9? If you thought 3 times 3, then you are correct. So in this little table, I have listed out the factors of 6 and 9. I want y'all to see, is there a number that they have in common with each other? Is there a factor that 6 and 9 have in common? If you're over here screaming at the screen, Miss Soto, 3, then you are correct. 3 is a common factor of 6 and 9. So over here, back in my ladder rung, I'm going to write 3 on the outside because 3 is the factor that both 6 and 9 share. So now I'm going to do like how we did at the top. I'm going to divide 6 divided by 3 and then 9 divided by 3. Who knows, if you're working this with me right now, what is 6 divided by 3? If you're saying it in your head or saying it out loud, it is 2. So I'm going to put 2 in this little ladder. And then what is 9 divided by 3? If you're saying it in your head or saying it out loud, 3. So now we are left at the bottom of our ladder, 2 and 3. Are there any numbers that can be multiplied together to give me 2 besides 1 and 2? And are there any other numbers that can be multiplied together to give me 3 besides 1 and 3? What do y'all think about this? All right, if you're thinking like, nah, Miss Soto, ain't nothing else there. You can only do 1 and 2 and 1 and 3. Then we're done doing the ladder method. So once we've gotten to both of our numbers being prime numbers, remember a prime number is a number that can only be multiplied by 1 in itself to get that answer. So 2 and 3 are prime numbers because there's no other numbers we can divide by besides 1. So once we've gone to prime numbers, we're done. We are no longer having to factor out, but we still haven't found our greatest common factor. Remember, the greatest common factor is the largest number or the largest factor that 12 and 18 have in common. So how we're going to do that is we're going to take the numbers on the side, which in this scenario is 2 and 3, and to find the GCF, we're going to multiply them. So I'm going to do GCF equals 2 times 3. And last time I checked, 2 times 3 is 6. So 6 is our greatest common factor. So this was kind of a practice problem that I just wanted to show y'all real quick. And now we're going to get into the guided practice. So if you want to, you can pause this video after I tell you what to do. So you're going to have to pull up your guided practice.